Hello, Algebrainiacs. To the next video. It is literal equations and rearranging formulas. So if you just write literal equations, that's probably good enough. And I think I'm finally teaching you something that you haven't really done too much of. You might have done a little bit. You may have dabbled. But literal equations are equations... Well, you'll see it. I don't want to spoil it. The learning target today is I can solve equations that have many variables. So that's kind of a clue. And solve is in quotes. So there's a lot of methods for solving equations that have many variables where you actually find what x and y and z or whatever are. We won't be doing quite that, you'll see. So I start off with two equations that are just two-steppers. So I'm going to go super fast. We know what to do here. We follow the rules of algebra. We do something to one side, so we have to do it to the other side. All that still will apply today. Alright, for this one, you know, we just, same thing. We got to deal with negatives. We got -9 here, divided by -3. Alright, all very normal. So that's not what we're learning today. You already know how to do that. What we're learning today is this. So the task was to solve for x on the first two, and it's the same for this one, solve for x. And notice it's set up very similarly to the first two. If you imagine a, b, and c are just numbers, then we're just going to do the same thing. If you notice on the first two, we added this term to both sides. We're still going to do that. We're going to add b to both sides, and that gets rid of it right here. So your goal is to still isolate the variable you were solving for. And in this case, it's x. So I add b to c. That does not make a new letter. You don't get to make up new math. We can just say c plus b now. And this is the whole idea behind literal equations, is that you're really just rearranging them. There's nothing we can do. We don't know what x is because we don't know what any of the letters are. What we can do is represent x in terms of a, b, and c. And if you've ever heard that in terms of and not know what they're talking about, in terms of means I'm leaving those things in my answer. So last year, you might have left your answer in terms of pi, right? In terms of pi. That's like saying x equals 3 pi and not 9 point something, which is what it is if you were to estimate and multiply by pi. Alright, so we got to keep going because we have ax. So to get rid of the a, just like I get rid of the -3 here and the 2 here, is to divide by a. That cancels this. It becomes 1x, or just plain x. But I also have to divide this side by a. And I'm done. C plus b over a. And I really like literal equations. I think they're more like puzzles. You can't check them, so that's nice. Like, maybe it's not nice, I don't know. It's nice to not have to do a check. But that's it. So you would use these in lots of ways, and that's usually the question. When am I ever going to use this? If you're an engineer, and you just have this book of formulas, you probably don't need that whole book. You probably just grab the formulas that you use on a daily basis for this project you're working on. But maybe that formula is written in terms of, or maybe it's solved for Q and you need it solved for S. So you rearrange the formula so that when you go to use it, it's way more efficient for you. Alright, so we're just going to do a bunch of examples so you can see what it's like. This is the first time you've ever done this, so examples are probably a pretty good idea. So for this one, it says solve for A. Again, this would have been more of a like in class, you guys practice now because it's really almost identical to the last one. Ax minus b. Oops, duh, I got rid of that. Ax equals c plus b. So it starts the same, but this time I divide by x instead, so the x goes away. So you can see I take the same original formula, but it can be solved for any letter you feel like. This down here, a equals length times width, that's area equals length times width. We all know that formula. But let's say you were always trying to find the width. The width was the thing that's always missing for the problems you're doing. Well, you can make it a lot easier by just dividing both sides by L. This L goes away, And now you have width equals area over length. I like to do the curvy L. So now you just take your area divided by your length and you always get width. So you can see how that's quite useful. Alright, let's try some more here. Alright, here is a popular perimeter formula for a rectangle. You have your length and your width, you add them up, multiply by 2 because there's 2 each, and that's your perimeter. But let's say, again, you just never knew your width. So we're going to try to get that to be the thing by itself here. So to do that, I got to undo, kind of go backwards here. I can't really get rid of the L yet because it's a part of this big system, but I can get rid of the 2. This 2 times this whole chunk is what's happening, so I'm going to undo it by dividing that whole chunk by 2. That cancels out the 2 out front, like that. You can't do that with L or W because they're not factors. They're not being multiplied together. But I have to multiply or divide this by 2 as well. So now I have P over 2, or half of P, equals, now I just have L plus W, and I don't really need my parentheses anymore because it's not, there's nothing on the outside of the parentheses. And now I can just get rid of the L by subtracting it. So I'm going to rewrite this with W in front. W equals half of P minus L. And there's that one. Alright, here's another popular formula. This is triangle formula, 1/2 base times height. And what if I want to know the height every time? I knew the base, and I knew the area, but I need to know the height every time. It'd be worth getting it down to just h. These are all factors. I could do this all at once, but I'm going to show you piece by piece. I'm going to get rid of the 1/2 first. I'm going to multiply this side by 2, because everyone knows 2 times 1/2 is just 1, and I have to multiply this side by 2. So I have 2a equals bh. And I'm solving for h, so the b's got to go. And my final answer is h equals 2a over b. It's really important in these, since they're all letters, that you maintain the capitalization or non-capitalization that it started with. It'd be very confusing if all of a sudden you switch to a capital H and a lowercase a. So just keep it the way it started. Alright, let's try some more. Flying now. Solve for t and then solve for p. It's the exact same equation, but this time we're solving for 2 different things. You can see how it works out differently. So for t, I need to get rid of... oh, this one's different. I forget. It has two p's in it. So this is actually your first introduction to what happens with when there's some of the same letters. So what we can do is, it's kind of my beginning class, because we didn't have a name for it yet, because you learned this later in the year. We called it undistributing. So if you imagine this P gets distributed to 2 different parts, P times what is P? That's what you're thinking about. So it's a 1. And then P times what is PRT? Well, P times RT is PRT. So it must have been multiplied by RT. So you can see, if I distribute that, I get back to this. So what I want to do is rewrite it like that. And that's going to make it easier to get rid of the things I need to get rid of. So I want to get down to t. I'm going to divide out the p, just like I did on the last one with the 2. So now I have a over p equals 1 plus rt. And then I'm going to subtract 1 from both sides. And then I get a over p minus 1 equals rt. And then you can divide by r. And this one's a little ugly looking, but it is right. T equals a over p minus 1 over r. And I'm pretty sure there's probably a better way to do this one if I did it a little differently. Alright, for this one it says solve for p. So we're going to do the same exact start. So we're going to rewrite this as a equals p parenthesis 1 plus rt. Just we're going to undistribute it. If you really want to know, it's called factoring later. And I know you know that word, but we haven't really factored expressions. So we'll call it undistribute for now. And I want p by itself. This one's actually easier. I just take this whole 1 plus RT factor, that chunk I'm multiplying by, and divide it all out. It can go away all at once because it's being multiplied by the p. And I just put it under here, 1 plus RT. And I can just cheat. I'm going to cheat and circle that. That's my answer. P equals A over 1 plus RT. So you can see they're just very different. So what's next? Solve for M. So here's, this one's going to be a little different. Actually, the bottom one's going to be a little different. Let's see what the top is. So it's identical formulas again. Same technique as I used before. I want to multiply by 2. Now maybe you're asking, hey, if I multiply by 2, shouldn't I multiply all of this by 2 as well? Well, in an equation, when you multiply the left and the right side of the equation, you only do it once, no matter how many terms, excuse me, how many things are in each term. You just multiply each term only once. So since all of this is one term, you just multiply 2 one time. And that cancels that one. And you get 2k equals mv squared. And then you just multiply that v squared out of, or divide, excuse me, divide that v squared out of there. And I'm going to cheat again. And you say m equals 2k over v squared. Actually, I shouldn't cheat. I shouldn't teach you to cheat like that. There you go. There's the final one. And this one here, so this is going to be a little different. Same exact start. We want to isolate the v though, so multiply by 2, multiply by 2. You get 2k equals mv squared. This time we want to get rid of the m, so that's gone. But now we have this pesky squared stuck to the v. And so far we just keep doing the opposite. Do the opposite to get rid of it, to undo what's being done. V has been squared. The square root is the opposite of squaring. So you show that by taking the square root of both sides. So when you square root a squared, it just goes back to the original. And that's the idea there. So we get v equals, and this you can't do anything more with it, the square root of 2k over m. There it is. Alright, this is going to be our last one, and it's really a tricky one. It says solve for x, and if you notice, this happens quite often. There are 2 x's. You cannot, I repeat, cannot have an equation that says x equals, and then have x over here somewhere. You can't say like x equals x over t. That just doesn't work. Because if you don't know what x is, you have double problem. So our job is to combine those x's, and it comes back to the undistribute thing. But we have to get them by themselves. So that means I want all of the x terms on one side and all of the non-x terms on the other side. Right now they're not on the same side. So I'm going to bring this cx over by adding it, because it's negative over here. I'm going to add it to this side. That gives me ax plus b plus cx, so that went right there, equals d. Now they're all on the same side, but I have this b that I don't want on this side, so I'm going to move that over by subtracting it away. Now I have ax plus cx equals d minus b. So you never lose anything, you just move them around. Now I can undistribute the x. I can imagine what that x had to multiply to be ax and cx. To get ax, it had to been x times a. To get cx, it had to been x times c. And it was positive, so you put a plus sign. So you're kind of working backwards. Now I can tell that ax plus cx is the same as x times a plus c. And that's what I want to write. Now you may want to listen to that part more than once, because that is a very new thing, this whole idea of undistributing, just to understand what's happening. So I came up with that by thinking, what has to happen if I want x to be by itself? And that's what I came up with. Now it becomes very easy. There's one step left, actually. To get x by itself, I get rid of the factor that's attached to x, which is a plus c. That makes this whole thing go away. I put it under here. And I'm done because I'm left with just x on the left. D minus b over a plus c on the right. So this has definitely been probably a weirder experience compared to what you've done up to this point. What you've done up to this point seems like review, I'm sure. But this one actually is one of my favorites for the whole year. I have fun doing it. A lot of the kids last year did not, but we're going to try to make it a little bit more fun. All right, just over 15 minutes. I don't want to keep babbling on. Good luck. Please ask a question in the question column. Maybe you'll have more questions this time. And please don't make your question, I don't get it, how do I do this? That's a terrible question. Okay, I'll see ya.